हेलो स्टूडेंट। ये अपने एमएससी सेकंड सेम का फोर्थ पेपर है जिसके चैप्टर का नाम है ग्रीन केमिस्ट्री। ये पेपर का नाम है ग्रीन केमिस्ट्री एंड एनवायरमेंटल साइंसेस। तो उसमें एक पार्ट है ग्रीन केमिस्ट्री का। तो हम ग्रीन केमिस्ट्री के बारे में समझते हैं कि ग्रीन केमिस्ट्री है क्या, इसके क्या प्रिंसिपल्स हैं, किस तरह की रिएक्शंस है, उसके बारे में जानेंगे। सबसे पहले हम देखते हैं कि ग्रीन केमिस्ट्री है क्या, इसका डेफिनेशन क्या है, उसका इंट्रोडक्शन के बारे में हम बात करते हैं। ग्रीन केमिस्ट्री इज एन इन्वेंटिव साइंस based on fundamental research towards the development of new sustainable chemical processes. There is a great need to create a new type of chemistry focused on a new production system in order to prepare the younger generation to get a greener future. The term green chemistry, also called sustainable chemistry, is defined as the invention, design, and application of chemical products and processes to reduce or to eliminate the use and generation of hazardous substances. While this short definition appears straightforward, it marks a significant departure from the manner in which environmental issues have been considered or ignored in the upfront design of the molecules and molecular transformations that are at the heart of the chemical enterprises. Looking at the definition of green chemistry, the first thing one sees is the concept of invention and design. By requiring that impact of chemical products and chemical processes are included as design criteria. The definition of green chemistry inextricably links hazard consideration of performance criteria. Another aspect of definition of green chemistry is found in the phrase use and generation. Rather than focusing only on those undesirable substances that might be inadvertently produced in a process, green chemistry also include all substances that are part of the process. Therefore, green chemistry is a tool not only for minimizing the negative impact of those procedures aimed at optimizing efficiency. Although clearly both impact minimization and process optimization are legitimate and complementary objective of the subject. Green chemistry, however, also recognized that there are significant consequences to the use of hazardous substances ranging from regulatory handling and transport and liability issue to name a few. To limit the definition of to deal with waste only would be address only part of the problem. Green chemistry is applicable to all aspects of the product life cycles as well. Finally, the definition of green chemistry includes the terms hazardous. It is important to note that green chemistry is a way of dealing with risk reduction and pollution prevention by addressing the intrinsic hazard of the substance rather than those circumstances and conditions of their use that might increase their risk. Why is it important for green chemistry to adopt a hazard based approach? To understand this, we have to revisit the concept of risk. Risk is, in its most fundamental terms, is the product of hazard and exposure. Risk is equal to hazard into exposure. A substance manifesting some quantifiable hazards together with a quantifiable exposure to that hazard will allow us to calculate the risk associated with the substances. Virtually all common approaches to risk reduction focus on reducing exposure to hazard substances. Regulation often require increase in control technologies and treatment technologies, and in personal protective equipment such as respirator, gloves, etc., in order to reduce risk by restrictive exposure. By achieving risk reduction through hazard reduction, green chemistry addresses concern about the cost and potential for failure of exposure controls. Regardless of the type of exposure control, ranging from engineering control through personal protective gears, there is always going to be an upfront capital cost. To what degree this cost can be recouped will be situation specific, but it will always be there. In contrast, there is a no additional upfront capital cost necessarily associated with green chemistry. While some green chemistry options may require capital investment, others may actually lower total cost of operation from the outset. This result is frequently the case in some of the easiest way of implementing green chemistry technologies. Exposure controls, because they rely on either equipment or human activity to accomplish their goals, are capable of failing. Respirator can rupture, air scrubber can break down, and so forth. When failure occurs, risk is maximized because the resultant exposure is to be a constant hazard. Green chemistry, in contrast, does not rely on equipment, human activity, or circumstances of use, but instead changes the intrinsic hazard properties of the chemical products and transformations. Consequently, green chemistry is not vulnerable to failure, as are the traditional approaches to hazard control. The definition of green chemistry also illustrates another important point about the use of the term hazard. This term is not restricted to physical hazards such as explosiveness, flammability, and corrosivity, but certainly also include acute and chronic toxicity, carcinogenicity, and ecological toxicity. Further, for the purpose of this definition, hazards must include global threats such as global warming, stratospheric ozone depletion, resource depletion, bioaccumulation, and persistent chemicals. To include these broad perspective is both philosophically and pragmatically consistent. It would be certainly be unreasonable to address only some subset of hazards while ignoring or not addressing others, but more importantly, intensely hazardous properties constitute those issues that can be addressed through the proper design or redesign of chemistry and chemicals. Green chemistry encourages innovation and promotes the creation of products that are both environmentally and economically sustainable. It deals in environmentally friendly, sustainable chemicals and processes, as a result of which pollution is reduced or eliminated, environmental damages controlled. The benefits includes reduced waste, eliminating costly end of pipe treatments, safer products, reduced use of energy and resources, improved competitiveness of chemical manufacturers and their customers. Green chemistry ensures that both processes and end products are clean and safe. Use of green chemistry is growing because it is environmental friendly and also because of legislation and international agreement that aim to reduce pollution. One of the basic ideas of green chemistry is to prevent the production of hazardous and polluting material rather than producing them and then cleaning up. Industry efforts, reduction and eliminating of hazardous substance to save money, reduce inefficiency, and promote their brands to consumers who favor eco-friendly products are the major areas of emphasis of many industries today. It also seeks to promote the opportunity to green chemists to work in an environmental where they can align their interest in environmental with their passion. Green chemistry curriculum. When employees are concerned about sustainability, it leads to more innovative long-term solutions. In response to development in the industry, many universities are creating a green chemistry curriculum. Their efforts require addressing what green chemistry advocates call a fundamental problem in a chemistry education. A lack of toxicology training in US student can earn a doctoral degree in chemistry in a nearly every university and not have a demonstrated basic understanding of toxicology and ecotoxicology. How to design a molecule that does not disrupt the endocrine in some way. But this is a changing to program and course about alternate design principles, slowly shifting chemistry education. Thank you. We will continue to